Hey, what's up, Ziguanas? This is the special edition, the third of its kind of the 30 days of Zig coding challenge. Yes, I started speaking a lot of numbers and I confused myself. So why it's special? Because I will not do what I usually do in the regular daily streams. So I will not learn something new. I would rather go through the things that I went through so far in Zig, and I will code for the third and last time a small Tic-Tac-Toe project in Zig, of course. And there is also, I will also use this time to kind of like summarize what I've done so far and see what is the plan. What is the plan for the next 10 days? My name is Dusan. Welcome to Zignited. Like I said, two topics, summarizing what I've done so far, and then we are going to go back to coding Tic-Tac-Toe. So from the beginning, I went through majority of official Zig documentation for this version 0.14. So I went through mostly through all of these things and mostly in order, because sometimes they were referring each other, so I had to jump a little bit. But this is what I've been doing so far. So from literally hello world, comments, values, then assignment, operators, variables, integers, floats, operators are here actually, arrays, vectors, pointers, slices, structs, enums, unions, opaque blocks, switch, while, for, if, defer, unreachable, all these things, functions, errors, optionals, casting, 0-bit bytes, result, location, semantics, using namespace, comp time. So basically today I stopped here, case study, and I used not all of these things in these previous two versions of the Tic-Tac-Toe, but I went like what I covered up to that point when I practiced in Tic-Tac-Toe. I tried to use most of the things, but because I had already like streamed for 1 hour and a half and more, I couldn't cover literally everything that I went through before that point of time. So I kind of like skipped something at the end. But yeah, that was how I did the first and the second version of the Tic-Tac-Toe. And by the way, I updated those two videos, like descriptions. I finally posted on GitHub. So there is the version for the 10-day of Tic-Tac-Toe, and there is the version of 15 days, version of 15 days after version of Tic-Tac-Toe. And you have in the description of this video that I'm streaming currently, there is a link to GitHub. So I will post after today also the final version, the third version of Tic-Tac-Toe game. So this is what I covered briefly. What is the plan for the next 10 days? So I might not take a look into assembly. It is extremely interesting, but it's kind of not related directly to Zig. So yes, it is calling using syscalls from Zig, but it's kind of like different perspective, at least to say. Then let's see the atomics, placing functions. So I might go through these just to see what is the state, current state of these things. Then we have a bunch of these built-in functions, which are briefly explained here, as I can see. And let's see what is after them. We have build mode, single-threaded builds, illegal behavior, memory, compilation, compile variables, compilation model, Zig build system. So I don't know if I will dive into C. WebAssembly. Oh, this is something that I personally love, so maybe I will jump into it in this basic 30 days of Zig part, but maybe I will see. So I don't have any clue how much time it will take to go through all these things. So if I have time, I would love to jump into WebAssembly, but definitely I will do it after these 30 days of Zig. So I kind of want to cover the basics in these 30 days, so not to do something that I prefer, but yeah, we'll see. So that's the idea for the future plan, let's say for the remaining 10 days. And after that, I will, of course, continue in some other form. So I mentioned I'm going to create, first of all, I'm going to work on a tutorial. So this will not be streamed live. I will just like edit videos and record myself offline. And I will do deeper research on the topics, and I will condense them so they are shorter, so that they are in the form of tutorial, so that you guys can have easier time following things and have everything in a bit more organized way, because these streams are basically me brainstorming Zig, so it's not organized. I'm trying to kind of like follow some path, but basically it's brainstorming sessions of Zig. So that's one thing for sure that I'm going to do after these 30 days. The second thing could be something similar, where I will maybe focus on something and still do some live streams and do some live projects or something. So I will see. I will think about it. In which form I will continue, because I love this live streaming way of learning. So it's very interesting because I can speak with you guys. Hello, Robert. I was just literally speaking about this. So I like this interaction with people, and you guys help a lot as well. So that's why I would love to continue live streaming as well. So I will definitely think about what will be the form of live stream after the 30 days. So it will probably be some kind of project. And like I said, this other thing is the tutorial that I will be preparing and publishing here on the channel bit by bit. So that will probably be a bit slower, because if I have to edit, I will spend some time. That will take some time. So I will try to do as often as possible. Okay, so now also let me quickly give some thoughts about Zig in general in the first 20 days. So what I loved. So definitely these last few days were interesting. So this comp time specifically. So I think this is very, very interesting and useful. So the things that you can, for example, make a function that is callable both during the comp time and in the runtime. So you can then use it in comp time to optimize things and to basically generate some different versions of the same function by providing a type. And you can also use it in comp time. So not maybe the same function, but I wanted to say you can use, while you are building these custom functions, the versions of them, you can call some, let's say, helper functions, if you will, and you can use still these helper functions during the runtime. That's what I want to say. So this is definitely the part that I love. Generic data structures, so they're basically, here they are just like a few examples of a bit more advanced examples of the same topic. Definitely, I would say they are both the same topic, and I love it also. Print, this was also interesting. So to see how the print function runs under the hood and how they are using Zig to do that. So no macros, nothing like that. Then if I go back, this is also useful, of course, in more complex structures using namespaces. This also made clear some things. So how actually the memory is organized in Zig. So this was extremely interesting to go through. Then I also, in this part, in the casting part, I loved understanding how coercion is working under the hood. So I kind of jumped, how they say, in front of the train, right? Or what is the expression in English? So when I did the second version of Tic-Tac-Toe, I kind of needed these things. I needed to know these things that I haven't learned yet at that point of time, and that's why I struggled. So that's why there is still a bug. I will show how to fix a bug in a second in Tic-Tac-Toe. But this is something that would be extremely useful after 15 days when I did the tic-tac-toe for the second time. Then also these optionals and unions. I don't see them here, but they were also interesting. And yeah, so I came basically to functions. I already used functions in the previous version of tic-tac-toe, so I guess this is something where I were approximately after 15 days. And I didn't use switches in the second version of tic-tac-toe because, like I said, it already took like, I don't know, almost 2 hours to stream, so I simply didn't have more time to cover more things that I wanted. But that's how it is. Okay, so like I said, for the last time, tic-tac-toe. And this is the version, I believe, with a bug. So the state where I left off last time. Just see, yeah. So there is an easy fix. I found out about this using AI. So I asked it, like, I literally copy pasted the code and I said, like, I'm getting this error. What can be the reason? And then I was asking Gemini. I think I still have it here. Give me just a second to show you guys. So basically there is an easy fix. Let me first do an easy fix and then I will show you how I got there using AI. So it was, here is the call. And the problem was that I changed the moves to be a constant here, which basically means that I needed to change here the input of a function here for it to be constant, but I simply didn't know the syntax, so I tried to do something like this, or I don't remember exactly. But the syntax, the correct syntax is like this. So this is a constant slice of U8s. And if I run this way, it should run, I think now, if I remember correctly. Yeah, so this is now, again, the running version. So you have this version like updated with the without the bug on the GitHub. So that you can check for yourself if you want this version and also the previous before the refactoring for the first time. And Gemini that I used, give me just a second, I will show you. It's this one. Let me just scroll. No, this is not the one. Give me just a second. Sorry, I know it's not on the screen. I'll bring it to the screen in a second. Yeah, here. So this was my question. So I literally said this is my Z code and copy pasted the previous version without the fix, like literally what I showed you at the beginning. So I copy pasted the same code and then I asked at the end, I said I get this error, and then this is the error, so I maybe copy pasted something else as well, and then the Gemini started to brainstorm, and basically you can see here on the screen that it kind of went in circles for a while, and then it answered with the thing that I already said, that it's an error, and it says like, oh, like, no way, that was an error, and so on. So it was kind of expected from AI, but eventually did help. So this is where I actually saw the correct thing, and this was the missing piece of the puzzle that I use. So this is the way I like to use AI when I get stuck. So if I see, first I try to solve it on my own without any search or any help, like try to think about it, just to practice also the things that I know, that I learned so far about the topic. And then if I really get stuck and if I see, okay, I cannot do this on my own, it will take me too much time, even if I can, but sometimes I literally cannot. So then I just use AI and I get some ideas at least. Sometimes it doesn't help, of course, it will hallucinate, but it will make me think in the right direction. So in this case, it did provide me the correct answer. So this was the trick that I needed, like the last piece of the puzzle that I needed to solve the problem. And once I did it, it worked. Let me see what you guys wrote. Before it was constant slice of mutable U8s. Now it is a constant slice of constant U8s. Thanks for clearing it up. Zig, similar to C++ and other low-level languages, has double const for pointer. For pointer types. Mutability of the pointer itself and mutability of the data. Yeah, makes sense. Hi, Dev. Welcome. Okay, so let's see what I can do next here to practice the new things. Let me just first of all go through the code because I forgot what's there. Okay, so I have this function check winner where I receive this array, right, of 9 elements. I have if, so this is very nasty. I can change this. And then I have the draw board function, which again receives the array. And then, okay, this is pretty straightforward. This, I don't see anything that I can do to improve. Then this function user input, let's see what this, yeah, this is the most, not complex one, but with most inputs and the one that gave me problems before. So let's see, we have a board, which is a pointer to the array of U8 size 9. Then this one that is a constant pointer to the constant array of constant slice of U8s. Then the move that is U size, which is a pointer. Yeah, it basically changed everything to pointer. That's I remember that was kind of the idea, to practice pointers in this refactoring that I previously done. Current player U8, okay. That's because it's read-only, right? So that's why it's still not a pointer. Void is the return type. While true, then if board, okay, this is just like that. So I can maybe practice switch here instead of if or something like that. And definitely in the first one, which is like a nasty looking one. Let's see what else is there. This is the main font symbol. So this is a string literal. Okay. Then turn usize 1. Okay, okay. Current player, I get that dynamically, the index of the symbol. So I kind of alternate between these two depending on the turn. So every odd turn it will be the X. Every even it will be the O. Okay. Then I have the board, which is array of U8s. Okay. Then constant moves, which is now of underscore here instead of the size. So it's U8s. And we have these numbers here, which represent basically the index of the board. Then I can, so maybe I can do instead of this, maybe I can do what I've seen that they are doing with capture groups. For example, I didn't use capture groups, and I've seen that they generate basically the index as they iterate through something. So maybe that's something that I can use so that I completely delete this part here. Then what did I didn't do next? So print the board, then potential move. I define it here. Yeah, I call it potential because here, see, yeah, I cannot generate this. These are not, yeah, these are the moves, not the indices of the. Okay, but I did use indices somewhere. I forgot. I will see. These are the moves. This is a different thing. So this is so if I run the code, it will make more sense. Show you here. So this is how graphically the board looks like. So I used indices here, 0, 1, 2, 3, to basically mark the position of a specific character, right? And in this case, this is just like, because I simulate 2 players, because I didn't use the user input or anything like where would you like to play or something like that. So I just like in advance, I used this combination. So this is the first move of the player X, this is the first move of the player O, this is the second of X, and so on. So yeah, it's a different thing. I forgot. So literally like 5 days ago, I did the code and I already forgot what I did. Then while turn is less than 10, okay. Turn plus equals 1. So this is to generate 9 at the top, 9 moves. Then I calculate who is the current player, basically to get the correct symbol. So current player is a symbol of X or O, depending on the turn. Then I print whose turn is it. So this is, oops, this is this part here. So turn 3, it's the move of the player X. That's the point of this print. Then the next one is printing the board, like here, like the board with U8. So this is the Unicode position of X and O and underscore, because at the beginning they are all underscores. So these are underscores. 95. Then what I do next is I call the function to perform the user input, which is that one that I went through already here. The one that takes the move from this array of potential moves. So actually not array, but here it's a slice in this function. And then it takes it, sees if it's underscore there on that place, so to avoid making a move on the already taken position. Then if this is okay, if it's empty, then it updates that field, increases the potential move by 1 and breaks. But it increases anyway, so if you have, where are the moves? Begin, no, later. So if you potentially have an invalid move, it will still increase it here so that you go to the next one. That's how the logic works. And then after that user input, we draw the board, right? So the current state of the board, whatever it is. And then here I check a winner, call the function check winner for that board. Then I print if this returns true, and it will return only if it finds 3 symbols that are in a line in any correct order. Then if it finds it, it will print the winner is and whatever is the current player at break. Then if we reach turn 9, it means if this didn't trigger the winning state, then it means it's a tie. So that's why here only at the end I ask if turn is equal to 9. So if we came to this part, it's a tie. So then it prints tie, and then after the game loop, it just prints game over. So this is how the logic works, and in this case, I think, yeah, it's a tie. Let me see what you guys wrote while I was explaining. The current state is Zig multithread, yeah. So I haven't touched that part yet, but I've heard that it is. So I've never did something. I'm literally what I said at the beginning. That is where I met Zig. So I started learning Zig 20 days ago. Also, why are you not coding in IDE? Okay, this is the very common question I get. Okay, because when I started streaming, the idea was that I jump straight into coding without setting things so that I can spend the most of time writing the code. And I wanted, like, after, I don't know, few streams to install Zig live in stream. I wanted to show how it's done so that people can see. But then I thought about it because I'm running everything on I'm using Windows here. I stream from Windows, and I wanted to cover all the system, so I technically cannot stream. It would be a very complex to organize such stream that I can switch from computer to computer and show how it's set up. And also because this is kind of like what I'm going to do with this tutorial that I'm going to prepare. So I will show how to install Zig. I just wanted like to jump straight into Zig. Of course, I will install. I still haven't installed on my machine Zig, and I'm using this online runtime just to play with Zig. So this is the reason. Of course, I will use eventually. This is kind of like something that I say I will do it maybe in the next few days, and I'll never do it. I never do it. Let me see what else you wrote, guys. Robert is answering to Dev. That is an interesting question. Can you be more specific? You can create multiple threads. If that's what you're asking, you can integrate with kernel level APIs like IOCP or IOUring. There are community maintained async runtimes. Currently, there is a work done to make the API for those runtime standardized so they can be more portable. Okay. And then dev answers, yeah, pretty much wanted to know if you can create multiple workers and assign them things. They execute in parallel. Async is different thing. Yeah, it is. Can perform async ops on a single thread. Yeah, that's how JavaScript, for example, runs. It's not multi-threading language, and on Node it basically does that. On web they use web workers for that. Okay, so let me see. And Robert answered, of course you can create threads and give them work. Also sync primitives are here for them. There is currently no stackless routines. Also there is plan for them in the future. Thanks guys. Thanks Robert for explanations like always. And let me see what I can do first thing here. So I would like to address this large function input because I don't like these 8 conditions. So I can turn them into switch, but I still don't want 8 branches, and I don't want them to look like this, how they look now. So definitely I want to fix this. Let me see what I wanted. I had an idea here, something with capture groups, but not with this. I don't want to do it with this, with the board, where I loop through the board to print. There is a helper. So this is where this is just to assign, and where I draw here this one, while I less than 9, I plus equals 1, then yeah, let's try to do this, for example, just so it's not that, of course, this is just to practice things. Not that it will improve dramatically the codes, but just to practice these capture groups. So I've seen, let me remember, where is the example that I've seen? I think today I've seen one as well. Here somewhere. Here, yeah. So this is what I wanted to do. Something like this. So I will comment out this part so that I see what was the point. Actually, also this I. And let me try to do it as a capture group. So I want to loop through the board here. And this is the same. I want to generate the eyes that are in the same way like here. So starting from 0 and then until the end. So here I will call this, well, I can call it C. It's okay because I also called it here. No, sorry, this is formatted. How did I call? No, I didn't. I just directly injected board with that index. But in this case, I can call it C. That's okay. And then here, okay, they did something different. In this case, I can do what I need to do. So let me see from here. So now I don't need this part because it's 4. I don't need this part because of this. We generate indexes. So if I copy paste this part, it should pretty much do the same thing, except that I have to change not board I, but I want C instead. And let's say, I will have this, yeah, but this is still the same index, so it's okay. So then I believe this should work. If I take this C, which is the current character from the for loop, and then format it as the character, then I print it, and then I just say the same thing here. If I plus 1 modulus 3 equals, so basically after every 3 printed characters, and I also have here space after each character in the same time. So I print character and space 3 times, and then I want to print a new line. So this happens 3 times. So it should be fine if I'm not mistaken. Let's see if I can run this, and if it runs. Yeah. Looks fine. Okay. I've just used my first capture group. Nice. So this is for this one. Let me see what else. I think I didn't have any other ideas down there. At least not right away. Yeah. So then let's go back to some of these functions that I can still optimize. Let's do this one. This one is like kind of bothering me. So what I want to do, and I mentioned this before, that I would like to reuse this code for, I mean, not that I have to reuse it, I just want to make it reusable. That's the idea. So that in the future, for example, I can code 4 in line or anything, like if you have not 3 by 3 and 3 in line, but if you say, let's say, you ask a user how large board you want, and you say the user types, I don't know, 20 by 30, so that it can dynamically change. And then you say 4 in line is, let's say this game is called 4 in line. I guess some of you guys know which game I refer to. So standard game that where you have to do 4 in line, and you basically, so let me show 4 in line here, 4 in line. So this one, if you ever played this game, it's kind of fun. And why my Google is now laggy. So you throw these pieces from above, and you have this gravitation aspect of it. So it's kind of like Tic-Tac-Toe, but it's not two-dimensional that you can put anywhere you want. You have this gravitational aspect. So if you put here whatever is, like in this case red or yellow, then it will fall all the way down. So this could be potentially next project. And for this one, definitely, like, you don't want to hard code all the possibilities. Definitely, if you want to have even different sizes of the board so that you can customize, you cannot. Even if you wanted to, you couldn't hard code these questions. And even if it's fixed size, like this is bad enough so that you don't want to do this, you don't want to hard code, it will not work anymore. So that's why I would like to also optimize this, let's say, in mathematical way, so that I can then reuse this code and then do something like that 4 in line game or something in the future, but more for just like for fun. Let me see before I continue what you guys wrote. Where was I? What was, yeah, the last time? Dev says thanks, Robert. I also say thank you, Robert, for explaining and answering questions to people. Robert says also K. Porti and Andrew were working recently on M times N fiber scheduler, and how you say M by N, or how it's proper to say, schedule with Vutex implementation. What is Vutex? I know Mutex. Is it a typo, or I'm missing some something? Implementation, because I've heard about Mutex, I've never heard about Vutex. Maybe I missed something. This will be the part of STD, most likely once they solidify the standards API. I'm hyped for it. Yeah, it sounds interesting. Looks like you really like Zig. Yeah, Robert is a Zig head. Well, the language is great, especially for someone who comes from C++ background. Yeah, I can imagine. What's the transformation? Also, we use it at work to cross-compile our C code base. Yeah, that's cool, since it's still in pre 1.0. And who knows how long it will be. Yeah, so I know, for example, for Solidity, I use it since, what was the year when I started? I think I started learning it in 2018 or 19, I forgot. And it was in 0.6 or 5, I forgot what was the version back in days, and it's still like not one. At least I haven't seen if they updated. The last version that I used was 0.8 something, I forgot already. So it's for years, like 0. something. Since it's still pre 1.0, there are some sharper edges, but get fixed fast. and breaking changes are minimal between versions. Yeah, that's cool. You must be embedded in tech. Actually, no high perf servers. That's also cool. Nice, nice, nice. Okay, so let's go back to this function. So basically what I want to do, something like this. This is my favorite developer tool, so Paint. I like to use that. So what I want to do is something like this. I will not change the structure, so I don't want to do two-dimensional arrays. They're, I think, easier in this case, but I just want to keep the same structure so that I can play a little bit with math and Zig in the same time. So what's the idea? These are the indices. And at the moment, I'm hard coding. So if you check where is my code here? So 0 and 1, 1 and 2, and not equal underscore. So 0 and 1, 1 and 2, not equal underscore. So I'm literally hard coding. Is it this one? Is it this one? Is it this one? So 3 ifs for this and 2 for this. 8 ifs in total. So like I said, hard coding, not something that you want and not something that will be possible in more advanced situation. So what I wanted to do, I wanted to dynamically calculate the I. So if I have, let's say, this set as I, and then the index is 0, so let's say 0, right? If I say I or whatever you call it, doesn't matter. Then instead of saying 0, 1, and 2, I can say I plus 1, and I plus, oops, sorry for this one, I plus 2. Right, so this is to test this one. And this is, now I will have to, of course, change, not to change, I don't have a loop. So I will have to create a loop, but in a specific way that I can organize the code in this way. So this is the main idea. And then if I wanted to make this dynamically, so in Tic-Tac-Toe, it's a bit easier because I have only these 3 rows and 3 columns. But if you think about on larger scale, then you would have to know where to stop. So for example, if I'm looping through here, it doesn't make sense that I take this I when I calculate the diagonals. So of course for diagonals, it's a different formula. It's not this one. This is the formula for the row-wise check, right? So if you want to check the column, it would be I plus 3 plus 6, right? So I and then I plus 3 and then I plus 6. So even in this small tic-tac-toe example, you can see that you should do this only when your I is in the first row. So there is no point that you try here and you will go outside of the range. So if I try here, I and I plus 3, I plus 6, then I plus 6 will be here out of the range, out of the index, I'll say. So then you would have this limitation that you check for this only when your I is in the first row. And similarly, you don't want to, if you loop through all these numbers, so if you have like the array, like in this case, it's 9 integers inside, so you want to do these columns, row checks only when you have, let's say, when you are at 0, 3, or 6 position. So if you have modulus 3 and so on. So many different ways to do this, but this is the general idea, how you can make it dynamic. So that say tomorrow I want to reuse this code and I say, I have a user that says I want this board to be, I don't know, 20 by 15, so that you can easily scale this, that you can apply the same rules and see where is the last row, for example, where you can check the column or the diagonal is the same for both of them. So this is the idea, how to do this. And then I will see, so this will shorten up, it will make this function have less numbers of questions, less ifs, if you will, and then I will turn it to switch at the end. That's the idea. So definitely maybe an overkill for tic-tac-toe, but it will help for these larger projects if you want to scale this. Okay, so let's say that if I wanted to loop through all these and then print dynamically. Let's see if I go back. Where is my code now? Here. So instead of doing it like this, if I wanted to loop through, let's say I will comment out all these or these boards. And let's say I want to loop through all by default through, I will loop just, this is, let's say, the brute force, let's say the simplest solution. I loop through all of the indices. I don't consider what's the length of the sequence, the winning sequence, like is it 3, is it 5? So I just like loop through all of them, but I just don't check for all of them. It's almost 3 here. Bye, dev. Good night. Good night. So here, let's make a loop. And again, let's do something like this, just to play with, so that I don't have a while loop like before. I mean, here I didn't have, but I used while loops before. Let's say I'm going to do it in this way. So now I want to do this check. Let's first do the rows, right? So when I do row, when my I is 0, 3, or 6. So in this case, because I have 3 by 3, I can hard code it for now. Then I will dynamically change it probably at the end. So I can say like the n. So I will call, let's say, the number of the columns, or I can call it c, that it makes more sense that is the length of the columns. So let's say, or call size. Let's call it call size, just to, so that will be this thing. So call size. Then I will have, not call size, that's a better example. It's not size of the call, it's how many calls you have. So call number, let's say call number, or call n, short, call n. So that will be this dimension. This I will call row n, so number of rows. And, or let's swap the word. So let's say n rows, maybe it's number of rows and n calls, just to make it sound maybe more intuitive. So these are, let's say, the dimensions. I will fix them to 3, but then in the future it can easily be like a thing that user can input, but I will implement them. And then we want to also have the winning streak, I will say, or winning, how could you say that in English? Like how many things in line you have to, so winning size, winning line, doesn't matter. I will just call it win s, and then you can put this to your imagination. So these are the 3 constants that I will make them as constants now, because I don't need to do any inputs. I will not do any end user inputs here. So let me see if I provide them here as constants in the main game loop. And then, so this is theoretical because this is a game loop. Here I was speaking about this loop. So I shouldn't ask this in game. And potentially, so I'm speaking about if you were to ask a person how large a board they want, this is not something that you would repeat, of course, in a loop. It would be before. So it makes sense that I define them here as constants. So let's say before all these, so I'm hard coding here, and I'm not even going to check if this is 3 by 3 or something. I'm just going to expect that everything is fine. So I will say constant. What did I say? I said number of, let's do columns first. So let's set this to 3. Then I will do the same for number of rows, set to 3. And then, how do I call it? Win streak or win s, I think. So constant. Come on. Win s equals 3. Okay, so like I said, in the real world, you would actually ask a user to input this for this dynamic games, but in this case, because tic-tac-toe, I will never change it, and I will make it a constant, which now means if I want to call this check winner, it's not enough anymore to provide only the board, but I will also provide the here these three things. So number of rows, number calls, number of rows, and win s. So number of rows, number of calls. Did I call it like that? Calls. Yeah, calls rows. So I have them in different order, but it doesn't matter. And then win s. Okay, so this is now a different input for our function. And here now I have to receive them. So they are, let's make them U8. So I didn't specify the type, but let's say they are going to be U8s, so that we are going to support basically the board size up to 255 by 255 by design. So let's say this is going to be U8, and the same for others. Now I can change this into U8 up here. So this is going to be, so let's say n rows again, right? The n rows is the first one. I send in the call. Yeah, let's just copy paste, just that I don't make a mistake. Here. So this one U8 and all of them actually U8s. Okay. Now once we have these, now I have this board, this for loop that loops through the board. And now I want to do the rows first. So back to the design, what I want to do, I want to see if my I currently is 0, 3, and 6 in this case. So if I do my I in generic, so in this case it's 3, of course, because I set the value of number of rows and number of columns to the value of 3, but this should be in generic. In dynamic way, it should be modulus the number of columns that you have here, right? And what that is the n calls. That's how I call it, at least. So if in the future they change the number of columns to 4 or 5, this should work, right? So this is what I want to do. Modulus not 3, but dynamically modulus of n calls. So only if my I, when I do modulus n calls equals to 0, so only then, if this is true, I want to test this I plus 1 and I plus 2, because it would be dangerous to do so here, for example, because I plus 2 in this case would be, I mean, it will not be outside. Here it would be 3, but then you would check like if this is the winning situation, if these 3 pieces are a win. So this is not by the rules, right? So it's not in line. That's why. So sometimes it's dangerous because you're outside of the range, outside of the index is out of bounds. Sometimes it will be simply not a correct position, if you will. So let's then do this. If I modulus n calls equals 0, then I will do this part. So I plus 1 and I plus 2, if they're equal, instead of hard-coded version that I have now. So where is my code? Too many things open here. So let's do that, what I just said. So if I modulus n calls equals 0, then I want to check. So basically what I had here, I can copy any of these. I'll just copy one of these, and I have to be careful because whenever I copy paste, I forget to delete things. So here I want to say, instead of 0 hard coding, I want to say I. Instead of 1, I say I plus 1. And the same, wherever I have 1, I basically replace with I plus 1, and here I plus 2 instead. And again, I plus 2. So in this case, it doesn't matter if any of these is not equal to underscore because I ask if they are equal to between themselves. So it doesn't matter which one. So I can do I plus 1, I plus 2, or I without a plus anything. So now by this one line, I should have replaced, okay, this is the condition. I didn't say condition. Of course, I have to say if this, then basically I have already the code up there. So I can just return, yeah, it's a simple one. I can even type it, return true, return true. So now with this code here, I covered these first 3 because this is how I tested the rows if they're equal. So now instead of 3 ifs, I have this, I was about to say 1, so they're nested ifs, but technically I can make this a 1 if I wanted. This is more readable, so I would leave it as it is. So this replaces the 3 checks of for all the rows. So this is a row check. So I will make a comment. So this is a check inside of a row if there are 3 same, this is whatever you want to call them, characters. And in a similar way, I will do test for the colons. Let me see what you guys wrote. There is something that Robert wrote. Since they're consts, you don't need to specify the type. Aha, yes, you're right. Because during compilation, it will become time int on the right anyways, the literal itself, and then it will be inferred, right? Time int, and it will, of course, yeah, you're right. Let's, do you know, are there some advantages like speed of the compilation if you do specify the type? Is it going to influence dramatically? I mean, of course, not in this example. I have like 3 values, but in a larger real world project, how it works. And let me see what else you wrote. If they won't change at runtime, yeah, they won't. Yeah, in this case they won't. Yes, so you can either make them global and use them in the function directly, or mark them as comp time in the function. Yeah, thank you. The calls rows and to win count. Yeah, thank you. So now let's jump back to paint. So I covered this. So if I 0 plus 1 will be 1, 0 plus 2 will be 2, and I check for this row. And this is, of course, when this is equal to 0, when modulus. Then if I'm at the row 1, this will be false. It will not try to test these 3, or however, these 3, if you will. When it's here 2, it will not be equal to 0, the modulus part, so it will skip. Then if it's 3, it will be 0, so it will do the I plus 1, I plus 2 thing, so it will check this row, and then finally this row. So now I want to do, let me delete these things because it's kind of messy now. So I want to do the similar thing for checking the columns now. Let me see if I can undo all these changes, or okay, perfect, I can. So this is +2. So this is for the rows. Rows check. Now I want to do this, this, and this. And then if you see what is happening here, instead of I plus 1 and I plus 2, it is I. If it's equal, so I want to check if that is equal to I plus 3, right? Yes, 3. So here it will be 1 plus 3, 4, plus 3, 7. Here 2 plus 3, 5, plus 3, 8. So I want to check, this is my winning condition, just like to simplify it, I plus 6, right? So this is what I want to test. And in this thing, I want to do it only for these 3 numbers, when I equals to 0, 1, or 2. So this is only if it's in the first row, right? So I can ask this in many different ways. The easiest way is to ask if the I is lesser than the length of the row. And that is how I call it n calls, right? This is n calls. So in my case, because I set these two at the beginning, n calls to tic-tac-toe, because this is tic-tac-toe, I set it to 3. So in my case, I'm asking if I is less than 3. So it is in this case 0, 1, and 2 only. These 6 are not, so they will not apply this logic. And that's literally what I want. And in the future, if I reuse this code, if I, let's say, copy paste this function, so I don't copy paste the constants, I ask the user what is the size, like how many rows you want, how many columns you want. It could still work with the same call, with the same function signature, if I do it in this way, because then the calls and calls will be different. Maybe it's 5, then it will be like 5 numbers here, so 0, 1, 2, 3, 4, and it will still be correct. So you will just check in this one. Of course, there is then a different question. How, if you have, for example, larger number of rows, this will then not be the case. Then you have to think about in general, not only how many you have rows or how many columns, but together how many you have rows and columns, so that you understand. Because it could be correct that you also ask from here. For example, if you had 4 rows, then it's legit if you have the size of 3, then that you can ask from here as well. So it does not. So this is a bit oversimplified. I didn't want to go full in for this version. This is the version that is a dynamic version, but it still has some limitations. So you will have to synchronize always the number of rows and columns with the number of winning streak, like how many things you have for a win. If you want to have a more dynamic approach, then you have to adapt this code a little bit. So I will not do it today, because this is more about tic-tac-toe and more like practicing things and using some math, and that you have the general idea how you can do something like this. Then in the future, maybe I will do the next project. Maybe I will do this 4-in-line game or something like that. So then I will continue on this logic, and it will probably make more sense. Maybe this is a bit abstract on this small example like tic-tac-toe, but it will make more sense when I actually jump into something more complex. Okay, so for this size, which is fixed, this is what I said is correct. So I can just ask this question. If it's lesser than number of calls, then I only take that into consideration and I do this check here. So let's do that. Let me go back to the code one more time, and I will copy paste this because it's going to be very similar. And let's actually copy the comment, because I want to also write a comment that this is check inside of colon if there are 3 same blah blah. So now my question is not this, but it's if I is lesser than number of columns without 0. So this is a different question now. And now I say I, and then I plus 3. So I plus 3 and I plus 6 here. And then finally, if I plus 6, for example, is not same like underscore. Okay, so this is the second one. This should theoretically detect. I mean, I say theoretically because if I don't try it, even if I think it's correct, it can happen that I didn't see some detail, that I missed some error that I have in logic or syntax, whatever. And that's why I say should, but we can test it now. So I only need to change this because this is a tie. Let's first see if it will still be a tie, if it will not falsely detect a win. That's something at least that I can test now. Aha, there is an error. I probably forgot something to 76. Where is it here? What did I do? Sorry. I swapped type and the name. And the win streak, so probably not the only error that I have. That's why I run. I generally don't like to do what I just did, so I don't like to code that much and not test the things for this reason, because it can happen that a lot of things I make a mistake and it can chain. So in this case, it will not, because it's so simple structure. So it's not that you have like a call of a function that calls another function that calls another function, and that you can have some very complex chain reactions that you can cannot trace easily later and understand what happened. But even when I do something simple, usually I like to test after a few lines of code changed. I like to test the things. Let's see what's the next error. 7610. What did I do? Expected an identifier found colons. Okay. I'm literally blind. Yeah, I talk too much and don't look. Let's see what's the next error. 28, unused capture. I haven't used this one yet. Okay, because I copy pasted the previous version, so I don't. Yeah, I actually don't need this one because I'm doing the dynamic I, so I need I don't need the character itself. So I can still leave this for as it is. I will just dump C. So I will do it like this. So I will say equals C, like this. So of course don't need for in this way, but let it be, because I kind of want to practice these capture groups as well. What did it say? Unused function parameter. Okay, yeah, because I noted a lot of things and I don't use them all. So this win I don't use, I believe. Is that the one? And maybe even and rows I don't use yet. So I use number of columns only here, number of columns here as well. So yes, I still don't use number of rows, so I will dump them both for now, and then I will come back to it later. So let's see here, for example, I will dump them. Can I do it like this? Can I, not like this, but can I do this? Can I kind of like destructure and do this in the same time? No. So maybe it's possible to do it in a bit different way. Or if I put them, for example, in anonymous, in a tuple, in anonymous struct, and then this deconstruct. What does it say? Still unused and rows. Because I say calls instead. Okay, so rows, not calls. Okay, yeah, now it works. And let's see, just so the reason why I ran is for this to test, so it doesn't detect false win. That's okay. That's so I was expecting. Yes, I was expecting to see this. I was hoping that I will see this. This was like what I was expecting at this point. Let me see what you wrote. If it's fully comp time only, value they're negligible. Yeah, benefits of setting type. This is the answer answering my question that I said when I asked if it will be different if you have a large project and then you instead of depending on comp time that you explicitly set the type. So this is the answer. If it's fully comp time only value, they are negligible, like the performance differences in performance, like the speed of compilation, let's say. Benefits of setting the type. Also, it would be nice to make board size. This is now specific to board size. Depends on columns minus rows. You can make initialize like. Yeah, that's a great idea. All stem rows. Yeah, understood. All stems rows. Yeah, definitely. I will do that. Give me a second. Just how long am I in? It is already 1 hour long. So I will maybe do this on the next project. I will do this 4 in line or something. So then I will do what you suggested, so that I will try just to wrap this version as it is now, so that this doesn't become too long of a stream. And then in the next one, I can do that 4 in line or X in line, that you can set how many characters or pieces in line you want to have for a win. Okay, so this this version that I have now checks for the row and call. Let's try now to have a win before I move on to the next stage. Here I have to change the moves now so that I have a win situation, right? So did I copy correct? And in this case, I want, let's say 0 is X, then this is, let's say, I'll put it down, so 3. So I want to check the row first. So 0, then 1 for the X. This can be 4. Then here 2 for the X. This doesn't matter because it will be a win before. So I can literally leave it even in invalid state. It should, if it detects the win, it will work. If this code is updated to detect the win, if I don't have a logical error, the winner is X. Yeah, so it works for the row. Let's test. So I also can test, and you can guys play. So I will not test all the versions. You can play on your own, so that you have the code. You will have also this version of the code on GitHub, so you can test the combination where you try to see if it will detect the second row. So I believe it should work. If you find any logical error, please let me know. So I would just like speed up things that I don't spend much more time on doing this dynamic check for now. So I have fixed, I have tested the rows. I will test only one column. So for example, let me test this one, the last one, so that it's not the first one, but let's say the last one. So the last one has, let me go back to the pane. So 2, 5, 8 are the indices of the last one. And let me try to make it, it doesn't matter if it's X or no, I know that part at least works. So I will try X, make 258. Okay, so 258 should be the moves. So here 2, here 5, here 8, and again the others they don't matter, because if it detects, it will stop the game at this point. Let's see all the way down. Yeah, it detects the winner in the row. Okay, in the column. So then the next thing are diagonals. So I have one like this and one like this. I will also make them dynamic. And in this next project, then I will have a more interesting situation. So imagine that you have, let's say, 5 or 7 rows and columns. So then, and you say, I want 3 in a row to be a winning state. So then you will check this, like this diagonal. Then you want to check this one. Then you want to check this one. Then this one is the last one. You don't want to check from here because you're outside here. But you also want to check this one, and then this one, and so on. Like basically, you want to start from here. You will then consider what is the number of rows, number of columns. You will do the minus what Robert suggested. And then you would have correct detection. In this case, because it's so simple, I will do it dynamically just to have the same logic everywhere. But in this case, it's an overkill, but it doesn't matter. And I will not do, like what I said, this pool logic that will work in the scalable board. I will just do the one that will do basically the same thing what I did so far for the rows and columns. So I want to do 0, 4, and 8 only when the index is 0. And I can do, so it doesn't matter. You can also do, there is no, the direction is not important. So I could have easily said, I want to do this diagonal check only when the index is 8, and then I can do minus some calculation. So in this case, it would be -4, -4. But if I say I will do it only when it's 0, I will then do it +4, +4. So again, does make a lot of sense in this case. But I just want to have something that will look like the fully dynamic solution, logical solution for the larger boards that will work on larger boards. So this is kind of like introduction to that, just to make you think in that direction. what we are going to repeat. And then, of course, in the full version, we will dynamically apply this +4. So it will still be, in this case, +4 will work. But just like this initial condition, where you say when to do plus here, where it was here. So this is the point, that here in this condition you have that you consider the number of columns, number of rows, and what is the winning streak, how many things in line you want to have. This will be basically the same, and this will be dynamic. Of course, in this case, it's like comparing 3 times, but it will be dynamic. If you say 5, then it's not going to compare only the first 3. It will dynamically repeat this that many times. So there will be another loop here, basically. So that's the idea. But at this moment, I will just do a simple thing. So I will just say here, if I equals 0 literally, then I want to say if I equals I plus 4, because I'm going from top left corner to bottom right, so I will do +4 thing. And then if +4 is equal +8, and then if +8 is not equal to underscore, so this is for this diagonal. And let's see the last one. So 2, 4, 6. So I can do if the I equals 2, then +2 +2. That's the idea. And in this case, I can also say, instead of hard coding 2, I can say, let's just use some of these things. So it will not make sense what I will do, but then I will not do it, yeah, if it doesn't make sense. I was about to just use like one of these that I'm dumping, like either the number of rows or the winning streak, but it doesn't make sense. It's better to leave it hard-coded than to make something that really doesn't make sense. So then I'll just leave this as it is, and I will just copy paste this one more time and do that other diagonal. And I will do it like in that order: 2, 4, 6, so +2. So if I is 2, so if I'm in the top right corner, I will do I plus 2, and I plus 4, right? So let me just double check. Let me double check. And I will also double check. So +4 +8, yes. +2 +4, yes. That's the correct thing. Let me double check. I plus 2, I plus 2, I plus 4, I plus 4. Yes, that's, I think, what I wanted. And then let's run the code for a diagonal. Let's see if it will detect. So for diagonal, I want 0. Here I want 4. So then I will just make this 5 and 8. And again, it should be enough. Doesn't matter what is after, because it should detect 0, 4, 8. Let's see. The winner is X. Yeah, it sees the winner is X in this diagonal. Let's make it 0 to, how it was, I already forgot. So 0, 4, 6, 2, 4, 6, not 0. So 2, 4, 6. Did I say 2 here? Just to double check. Yes, 2, 4, 6. Okay. So then let's try 2, 4, 6. If it will detect it. Yeah, it did. So yeah, this basic logic works. The basic logic works. So I'm still not using this number of rows and the winning streak variables. So I will not do this in Tic-Tac-Toe. It doesn't make sense. So I will just leave it as it is, as introductory part for the next project. I will just leave it as it is. And in the next project, I will do the more dynamic and the real thing. Let me see what you wrote. Translation probably won't work like I wrote it. Just in the showcase how to do it by star operator. Yeah, I will definitely play with this next time. Okay, how much time I I'm on already streaming, so about 1 hour and 15 minutes. So I don't have a lot of time left if I don't want to make this very, very long stream. So maybe I can even stop it here. Or at least if I can do a switch here instead of these base case conditions, if I just can convert it to a switch, for example. Or if I have some other if, because I've just made this one. Is there any other that I can quickly know? These are, okay, maybe here, so that I have it here. If I switch instead of, but they're taking different things. Yeah. No. So up there I can switch I because I test I all the time, but here it doesn't make sense to do that. Yeah, let's leave it as it is. Let me just think. At least I played with capture groups, and I did this logic here, which is the math logic. And maybe, yeah, let's stop it here. So I don't want this stream to be long. I had some comments that I'm making these streams very long, so I don't want to do an not overkill, but I don't want to make this longer, even longer. So I guess I will stop it here. Then in the next one, I will play more with these things. Yeah, it took me too long of this this math thing to explain, and everything took a bit more time than I expected. So that's why I will not start a new thing now. And let me just see quickly if I can do something very, very fast that would be useful. I would probably play with this course, but I will not start that now because I'm already literally close in the hour and a half. So I will stop it here then for this stream, and I will push this to GitHub, this version of the code, and then we can continue next time. So tomorrow, the idea for tomorrow is that I will do the regular day 21 already. So I think I will start from here. If I see, yeah, this is actually very short and it's to do. So I guess I will start then with async functions and built-ins. Nah, they are also very short. Repressed with the release. Regressed, not repressed, sorry, regressed. Okay, I will see this tomorrow. So I will probably then start with built-in functions tomorrow. That's the plan for tomorrow, and I will then see what's next. That's the idea. Okay, sounds like a plan. Thanks, guys, for being here today, and see you tomorrow. Bye-bye.